Hi, Algebra 1 students. These notes go with lesson 17 and lesson 18 in module 3, and these are notes on transformations of functions. So we're going to fill in some of this chart now, and the other piece of this chart we'll fill in during class tomorrow because we're going to kind of explore another characteristic or another transformation and then draw some conclusions on here. So we're going to start with vertical shifts. So this is where your graph is moving up or down. And what we see in our equation, so in the first column, it's describing the transformation in function notation. So it says y equals f of x plus k. So what are we doing to the equation? We're adding a positive number to the end of the equation. So we looked at examples like this in class. So it's something like if I said a of x equals the absolute value of x, and then I would add some number to the end. So remember, this k means a number. This is a constant or a number. Okay, and what we saw in class was that when we added something to the end of the absolute value graph, it shifted the graph up k units. And we can draw a little graph to represent this. So if this is my original absolute value graph, then if I added some number to it, it would just kind of shift that whole graph up. So the pink one is the new one. So then we also looked at today was f of x minus k. So when you're subtracting, the idea is we're subtracting a positive number from the end of the equation. So an example would look something like b of x equals absolute value of x minus 4. And what we saw on the graph during class was that it shifted down. The whole graph shifted down by k units. So if I was to sketch a little picture here, we have our original v in green, and then I'm going to draw the new transformation in pink. So notice all we're doing is dragging the graph down. We haven't changed the steepness, we haven't changed the size, we're just moving it around on the coordinate plane. Okay, now we're going to look at, the next one is a reflection across the x-axis. Okay, so what we saw in class was if we put a negative sign in front of f of x, then that was going to reflect it over the x-axis, or flip it upside down, basically. So what are we doing through our equation? We put a negative 1 in front of the whole equation. So that would look something like c of x equals negative absolute value of x. And this is going to flip upside down. So I'm going to write this more casually. So the formal language you would say is a reflection across the x-axis, but really what we're looking at is a flip upside down. Now I'm going to sketch a little picture. So the original graph is an upward facing V. So now I'm going to draw one that is a downward facing V. Okay, next up we have a vertical stretch. So this notation might look a little bit confusing, but it says y equals k times f of x. So that means we're multiplying by a number out front of f of x, but we're saying k is greater than 1. So k is some number that must be more than 1. Then we will get a vertical stretch. Okay, so an example of this would be if we put we multiplied 3 times absolute value of x. So 3 is my k value. 3 is a number that is more than 1. Now, I could also have a decimal, so it could be something like 3.5 or 1.5. That would also create a vertical stretch. And what we see on the graph is that it's going to get narrower or skinnier by a factor of k. So I'm saying factor of k. Factor means multiple, like something you're multiplying by. So you're multiplying by 3, so I'm calling it a factor. So graphically, if I sketch a little picture, we have our original v, and then remember what I did in class where I kind of stretched my arms up, so we can imagine it's getting steeper on both slopes. So both slopes were before were 1 and -1 here. So now if like I multiplied by a 3, then this would be like a slope of 3 here, and this would be on the left-hand side a slope of -3. Okay, there's also a vertical shrink. A vertical shrink is where you still have y equals k times f of x. So it's related to these things, to the vertical stretch, except now we're saying k is between 1 and 0. So that means it's some sort of fraction or decimal that can't be greater than 1, and it's not less than 0 either. Okay, so under our change in the equation, I multiply the whole equation by a number between 0 and 1. So that might look something like, if I did like 1/3 times absolute value of x, or I could do like 0.3 or 0.2 or something like that. It could be a decimal as well. And now this is going to make my graph wider, or it's going to give me a less steep slope. I'm still going to describe it as a factor of k. So I'm saying it got wider by a factor of k because I still multiplied by k. Same situation, except now my k is a fraction, so it's going to make all of my y values kind of like shrink down. So what we'll see on the graph is where we used to have the regular slopes of -1 on the left and +1 on the right, we're going to get a less steep slope, some sort of fractional slope. So it should look something like that. And I am not going to talk about horizontal shifts right now. We're going to film this last part of this tomorrow in class. Okay, but let's look at a couple of examples now. So it says let f of x equal the absolute value of x. Write a formula for the function whose graph is a transformation of the graph of f given the description below. So that's a lot of words, but basically, this is saying, oh, actually, the first one's talking about a horizontal shift. So we're going to skip this one. We're going to come back to it tomorrow. And we're also going to skip C. So we're going to look at B and D. So the idea here is, B says I have a reflection across the x-axis and a vertical shift down 7 units. So I'm trying to write an equation that does both of those things. So a reflection across the x-axis, if I look at my chart, the reflection is where I put a negative sign in front of the absolute value of x. So I'm going to kind of like write that right above here. And then a vertical shift down 7 units would mean I'm subtracting the absolute value of x by 7. But now if I want to do both of those things at the same time, then I kind of want to merge those two different equations. So I could say something like f of x equals, well, I'm going to put my absolute value of x because I know it's some transformation of that. I'm going to put the negative sign out front, and I'm going to subtract by 7. So this graph will both shift it down 7 and reflect it over the x-axis because there's a negative sign in front. Okay? So what I want you guys to try is, can you write an equation that will do a vertical stretch by a factor of 2 and a vertical shift up 5 units? So you guys try that one. Okay, you can pause the video, but I'm going to keep moving onto the back, or onto the second page of the notes. So on the second page of the notes, I'm giving you a graph, and I'm asking you to write the equation and describe the transformation. Okay? So we're thinking about how the graph we see looks different from the absolute value of x. So we're going to we call the absolute value of x like our parent function, because it is kind of like the most basic form of the absolute value graph would be where you don't have any sort of transformation done to it, but then you can think about other absolute value graphs as being like a child of this graph. This is the parent, and then it's sort of like an offshoot, right? So it might be helpful to kind of sketch in the absolute value function, the regular one. So it's very easy to do on the graph. I'm just kind of doing a slope of over 1 up 1 on the right hand side. and then over one to the left and up one to the on the left-hand side as well, right? So this is absolute value of x. And then I'm thinking about how does this other graph relate to it? And just to kind of like make it more clear, I'm going to just outline this. So what it looks like to me is that they have the same slopes, right? Because they are parallel. And all that's happened is I've kind of taken f of x and split it up, right? So we call that a vertical shift, right? So we see we have a vertical shift up 3 units. Now, if I want to write the equation that goes with that, it would be, I'm going to call this like, we'll say j of x equals, well, I got it, if I kind of refer back to the chart, if you need to, if it's a vertical shift up, then I should be adding something at the end. So I'm going to do absolute value of x plus 3. Okay, so I'd like you guys to try letter F. So again, you're thinking about how does this graph here, how is it transformed from the original graph of absolute value of x? So you could, again, you could sketch it in if that helps you. You don't have to always sketch it in, but you can think about how has this graph moved to get down here? And then what would the description be in words and what would the equation be? Okay, I'm going to do one more example, G, and then I'm going to let you guys do H, and we're going to save these 3 on the bottom for class tomorrow, okay? So in G, again, it might be helpful to sketch in the original graph of absolute value of x. And it also, just to make it more clear, I'm going to outline the graph that's already there. So the pink one is my original absolute value of x. So I'm thinking about what changed. Well, the green graph, it's still a V, but it looks less steep, right? It's still centered at 0, 0. So I didn't shift it up or down at all, but it's less steep. So if I think about which of these graphs makes my kind of line less steep or wider, right? The vertical shrink is the one where your graph is getting wider. So that's the one I need to think about. And then the idea is we're multiplying the equation by a number between 0 and 1. So the trick to these ones is that the slope of the new absolute value graph will always be the factor that you're multiplying by. So in order to figure that out, I could kind of think about calculating the slope of this line. So thinking about from one point on my green line to another, I went over 3 and up 1. Oh wait, I want to put rise over run. So I'm going to do up 1 divided by over 3. So that would be a slope of 1/3. That's kind of cluing us in to the fact that we are doing a vertical shrink. It's a vertical shrink because it's getting wider by a factor of 1/3. And then if I want to write the equation, again, you can always refer back to this chart. So if it's a vertical shrink because it's getting wider, that means I need to multiply the whole equation out front by the fraction, and that fraction is exactly the slope of like the positive side of the V. So actually our equation is going to be the same equation, right? Because we had a slope of 1/3. So when I go to write the equation, let's say P of x equals, I'm going to write 1/3 times the absolute value of x. And that would be an equation for this line. So I'd like you guys to give H a shot and think about what's going on in H. What's the transformation? Can you describe it? And then could you write an equation? And we will be practicing this in class tomorrow.